I like that. I like that. Well, ladies and gentlemen, I hope you had a good weekend. And ready to go. A little snow on the ground makes things always a little bit more interesting, ladies and gentlemen. 15, 2, 4, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15.
And she didn't care.
She normally doesn't care. And I told her about it. She was like, well, I think it's more important to give you feedback in your face. Okay.
Okay, but that's still
It's still in there.
She gives you feedback, and then you resubmit it, and then she just marks it as
And then she just forgets about it forever. Until you're like, hey, can you do it? She's like, I'm getting to it.
Right.
Okay. That's...
Then get to it
No, you're
faster,
not.
please.
No, you're not.
Get to it faster.
I thought I'd change this. Okay. So, ladies and gentlemen, today we're going to finish talking about heating curves. We started that the other day. Later this week, Thursday or so, we're going to be doing a lab you are going to need goggles for. Okay? Now, you will need goggles for this lab and multiple labs for me this year. So, on Thursday, I will have a box of goggles here from the front office. If you do not have goggles, you can buy a pair from the front office. You do not have to bring the money. They will simply add it to your school fees, and you will eventually at some point have to pay them. And they're about $2, $2.25 for a pair of goggles. If you have goggles, you can bring them to class. You do not have to buy the goggles that I am going to be selling you. But you do have to have goggles for the lab, so if you don't have goggles, you're going to have to buy a pair on that day. If you want to start bringing goggles tomorrow, Wednesday, so that you don't forget, I have boxes in here that I can store them in for you so that we do not lose them. They're here when you need them. Okay? So that's what you're going to have for later this week and for a lab that we will do next week as well. These are what I mean by goggles, ladies and gentlemen, not glasses. You might have safety glasses for shop class or for mechanics class or something like that that will cover your eyes. These seal around your eyes so that hopefully things don't drip into them and you don't end up getting something in your eye that you don't want in your eye. So again, I will have these here on Thursday. If you have a pair already from somewhere else and you want to bring them before then or on Thursday, that is fine. But you need to have goggles with you on Thursday for the lab that we will be doing. Okay? Questions? Wonderful, wonderful, wonderful. So, ladies and gentlemen, if you could have a superpower, what superpower would you want?
Is this a repeat question?
Did we do this?
We did the worst superpower.
Yeah, we did like the worst superpower ever, but we haven't done one we wanted.
No, I thought we did this one too.
No.
Guess you're wrong. Guess you're wrong, Cynthia. I know that's never happened to you before, but you know what? Oh, well, I guess we're through with that. So what superpower would you want if you could have one?
Me?
Yeah.
No, she's right. We did this, but then we turned it into a bad one. And it was like all the bad ones.
Okay, so we did the bad ones. We're agreeing on that.
Yeah. Yes.
Okay, so now what's...
And you guys just flipped it. Because you guys wanted to make it fun.
Okay, so now let's make it unfun and tell me what superpower you would want if you could have one.
I don't know what it's called, but when we can move things in your mind.
Ooh, telekinesis. Okay, so like you could move Nadia's phone into her backpack so she didn't get in trouble for it right now?
Yeah.
That would be cool. That would be cool. So you want to be able to move things with your mind. Okay. What's that?
Because I wasn't here Thursday and Friday. I caught a cold.
Why did you catch a cold? Why were you running after it?
What?
Well, you caught it. Why were you running after it?
Why didn't you just throw it again?
Why didn't you just avoid it? Yeah, you and Nadia got quizzes to make up.
Okay.
So, when you're ready, like now, you go take it right now, or when you're ready, you let me know, but you got to get it done by the end of this week.
Right.
Nadia, you got that?
No,
No what?
I didn't get that.
See, and you did get that because she used a double negative there. All right, what superpower would you want? Leaf, what superpower do you want? Shape shifting. You want to become a garbage can. Okay. Okay. All right. Shift your shapes. All right. All right. Miro. Any superpower in the world, you can have it. What do you want?
I feel like there should be downsides to some things.
Downsides? Okay.
Because if you have one, then you're gonna need another to make up for the bad parts of it. But like just anyone?
Anyone, but only one.
Super speed.
That's why.
Boo! Boo!
That's like dumb. You
That's
can
like
run
the
really
worst.
fast.
That's like the worst traditional speed.
Thank you.
I know. It's horrible. I hate it.
So why'd you pick it?
Because why
What
not?
benefit do you see to super speed?
There are no. There are downsides to super speed actually.
Well,
Then why are you saying that?
Brindley. Relax a little bit. Relax a little bit.
Okay.
Tell us yours so we can make fun of yours.
I don't know. I don't really. Nope.
that's kind of lame.
See, at
I
least
don't know.
came up
I
with
don't
an
really
answer.
know. I don't know. What,
I don't know. Like, I don't know. Give us a list.
make one up.
Make one up.
Sure. Who
Make
said
one
it had to be? Well, first of all, if we're making up superpowers, you can make it up to be whatever you want to be.
I don't know. I'm
How about
fine.
the ability to make decisions quickly?
That would never happen.
So
No
maybe
matter if I
that should
had
be.
That would have to be a superpower then.
That wouldn't.
All right. Jasmine, what do you want your superpower to be? Teleportation. Okay, now is this the kind of teleportation where you can just go anywhere, or you got to see where you're going to? Anywhere. Okay. All right. That would not be a bad thing. Get up one morning and be like, no, I don't want to be here. I'm going somewhere else. Okay. All right, Levi.
I don't know, like the ability to manipulate probability.
That would be kind of insane.
The ability to manipulate probability. What do you
That-
mean by that?
Make things
Like you
more
can
like-
make-
You can make
could
things
make-
more or less probable.
Yeah, you can make
So
something.
like flipping a coin, you can be like,
100%.
Lands on heads.
It's always gonna land on heads whenever I flip this coin.
I'd be the best gambler.
Not necessarily. I've seen people who've had sure things and they still blew it.
But they can't manipulate probability.
So in reality, what you want to do is be able to see into the future, so you know what card is coming, and then be able to bet on it.
No, because I can make it become the card that
That he has
that
at
I
once.
need
But then you're not manipulating probability.
when
You're
they're shuffling
manipulating
the
the
deck.
cards.
When they're shuffling the deck.
Okay. Jera? You like that? You want to manipulate probability? So you want your superpower to be something that nobody would know, but you'd make lots of money on.
Yep.
Okay. Fair enough. It's your superpower. You can do
If
it.
everyone knew, then it wouldn't be fun.
It wouldn't be fun.
No, because everyone would be hounding you all the time.
Every tip
Why?
something nice, you get
You gotta
$500.
Well, change the probabilities of people hounding you.
Please.
So you're gonna get the buttons. That's
So there you go. You don't have to worry about it then.
Yeah, but
And nobody else sees it.
Yes, I want that. I want
You
that.
seem like
That's
you
my
would want your
superpower.
superpower to be like master golf.
$500.
Nope, not even close. Not even close. My superpower, I already got mine. Don't worry about it. Jim, what do you got for a superpower? What do you want?
I can see.
I'll just have speed.
Speed? So you want to be fast?
You don't have
I want the
You can see me
flash.
killing myself.
Okay.
Not just these.
So you want all of his stuff.
Yeah.
Even the stuff they just made up to make it seem cooler because all he can do is run real fast.
No, this is-
Okay.
You can
Okay.
like, no, it's kill your sister or
Yeah.
He can like go through time.
Yes, if he goes
Because he
fast
goes
enough.
fast.
Time, I can go back
So,
in
like,
time.
that's the-
Okay. How fast do you gotta go to go back in time?
What an example.
Oh.
Well,
Oh,
yes,
it's
go
It's
through
not
the
exactly
process.
like it was measured.
Just to go through
Right?
something.
He can run at the speed of light.
Which is absolutely positively totally impossible.
That's
Exactly, that's why it's a superpower.
Right. I know.
Mr. Bear, why do you always have to hate on it?
I don't hate on
Yeah,
it.
what's
No,
your
that's
power?
true.
What is
You're a
your-
hater.
you-
What did I hate on? What was your superpower?
To,
Telekinesis.
yeah.
I didn't hate on that. No, you wanted to move things around. What?
So like, yeah.
What's your with her mind?
Hold on, we'll get to mine. We haven't gotten to Nadia's yet.
That's
Well,
your
I know you
superpower.
don't have
That-
one.
no,
The
that's
question
your
is, what
superpower.
one do you want
That's
to
your superpower.
have?
Your superpower is not to have one. in a world full of superheroes, she's the only one that doesn't have one.
She's like
Well,
Batman.
thank you for explaining that for her.
Batman.
She's like Batman.
Yeah.
I want my superpower to be really rich, so then
Exactly.
I can
That was his superpower. That was one of the greatest lines in superhero movies ever. What's your superpower? I'm rich.
really rich.
Naja.
And I have a
Najma,
deep voice.
sorry.
I want to be really rich and have a really deep man voice, so that people take me seriously.
I want to go through stuff.
You want to go through stuff like doors
Yeah,
that
anything.
are open.
Anything.
Anything.
If I put my hand through this, it wouldn't like hurt me. It would just go through.
But what would be the point of
Permeation.
that?
Well, if I'm stealing from a bank or something, I don't have to open it.
Okay, well, don't tell us
Okay,
your
but now,
plans.
okay, hold on then.
I can just manipulate.
So you can go through things.
I wouldn't go near you.
So you could go through things, but could the money you're carrying go through things too?
You're running through.
You're running through all of them,
Money
but all of a sudden all the money gets left behind.
Just say
I
that
can
you
turn
can
it
like
off and
make portals.
No, I can turn it off and on.
Hey, it's her superpower.
You just
Let
keep
her go
going
with
in
it.
and out, trying to get the money to point A to point B.
And then everybody's watching you go through the wall.
Pretty soon she's just like, can I use the front door, please?
What if you put the money in like your pocket?
I don't know. That's what I'm
And
asking.
try and go through.
That's why I
Yes,
asked.
I can turn it off.
Does it just like rip
Jasmine's-
through your pocket?
That's why I asked
I would say
Jasmine's
it's
superpower of she wants to be able to teleport. Well, there are some who
I mean,
say
that's
I'm able
what
to
we do
see where you're going,
normally,
some
but
who
if I
say
turn it
no.
off, it wouldn't. It would just stay in my pocket.
I mean, obviously, everything she grabs has to go through with her. It's not like she's gonna leave her clothes behind her.
Well, now wait a minute. She wanted. What if she goes to grab the money and she goes right through it?
Listen, it's my superpower.
Yeah.
I get to decide how it is.
But
Okay.
like, we're
Well,
just
you,
trying to
you
get
didn't
the
set your parameters
reality.
first.
I'm just.
We don't want you to go into a bank thinking that you're gonna rob it, and then you can't even pick
Okay,
up the money.
because here's the thing: if you're using your superpower, can you pick the one thing you're using it on, and not something else? So you got the money in your hands, and you're like, "All right, I need to use my superpower to go through the wall." So I turn my superpower on, and then all of a sudden, everything that you're holding falls through your hands because you can't hold it anymore.
But I'm saying, like, I can manipulate that. I can, like, turn it off and on. Like, I can decide when it goes.
So you can turn your hands on, but you can't.
No,
But then you're.
But then her hands are gonna be on the other side
Yeah,
of the
your
wall.
hands gonna go.
You know what? I'm done. I'm just gonna go with flying. I'm gonna fly. That's what I'm gonna do.
Okay.
I would fly, but I'm afraid.
I'm
of
done.
that.
Just okay.
Because your power
All
doesn't
right,
make any
Daniela, what do you think?
What's the point? It's
What's hey? Relax, relax. It's like Aquaman. What good does it do you to talk to fish? Anyway, Danielle, what do you got?
Listen,
What's that? Time warping. So be able to go now. You want to be able to go back or forward or both?
Well, and then slow down.
Slow it down
Or speed.
or speed it up.
Time warp the time.
Okay. All right. Rocio,
Probably move stuff.
move stuff. Okay. All right. Avant,
Teleportation.
teleportation. Be able to go somewhere. All right. Keisha. Have you been paying any attention?
Yeah.
Okay, what are we talking about?
Powers.
Okay, what one you want? Something.
Oh. That's
Oh,
my
you and
favorite
Brindley.
power.
You and Brindley got that something power. Okay. You got something.
Yep.
Read minds.
Read minds. What am I thinking now?
That'd be horrible.
Power.
Nope. Tacos are good. Tacos are good. That's what I was thinking. Tacos are good.
Yeah.
It's like, I'm amazed you couldn't get that. All right, Brenda, what do you got? Teleportation. All right. Jacqueline, did we ask yours? Jacqueline, what do you want to do?
no,
Stop time.
That wasn't the only one here.
no blessings on you.
So wait a minute. Run there by. You want to stop it and then what?
I can go to my house, speak for an hour, and then come back.
We don't need to stop time for that.
But then it would be missing class.
Okay, good point. Good
Wait a
point.
minute, I changed my power.
It might be useful.
Wait, you can't change your power. You have nothing.
Blessings might be
No, I thought about it. You give me like 15 seconds on the spot.
Yeah, no, that's why I
What's
kinda
that?
just jumped to
I-
super speed.
I told you what I wanted.
Nothing?
No,
Oh, no, you
I
wanted
want
to
to have
super
a
Hey,
speed.
hey. Hang on a minute. What you want to be able to do? What?
Convert energy into any form I want.
Convert energy into any form you want. Okay.
I mean, literally get whatever I
energy on fire.
Okay.
Yeah. I could like burn down a plane
Why would you burn down a bank?
with electricity. That's like pretty cool.
Why though? Banks got money in them. Take the money and say, Najma might be inside. You could burn
I
her
thought
down.
banks like don't.
No, she'll just run through the fire. It's okay.
Oh.
I thought they just like.
But then
store
see,
it.
The money will be
I was
burnt
talking
away,
about
but-
functions and how
That's-
space
I thought they
turns
actually
on.
don't know.
No, I don't
Probably not. It depends on the bank though. Some do.
Imagine like
Some don't.
I mean, like, if I'm converting energy in any form I want, would I be able to like convert gas? I mean, not gas, electricity into gas
Well, why would you need to convert electricity into gas?
to make everyone pass out so I can give money.
Like if I went.
Oh, like sleeping gas.
Yeah.
Your superpower, I guess you can do with it what you want. Okay. I'm gonna agree. I can't remember. I'm gonna agree with you, Nash. Not on the part where you can go through things. I'm gonna fly. Okay. There's one simple reason I want to fly, ladies and gentlemen.
Why?
I hate heights.
Then you can eventually get over it. But like I get
No.
that.
Why would you be afraid of heights?
What are
If
you
you
gonna
can
do
fly
with-
and never fall.
What are you gonna do with your power?
Actually, heights aren't what scares me.
You
Falling
can't do
down
it.
to earth is
No,
what scares
because
me.
you can, if you were flying, you're in the air, so your potential energy, and you can fall.
I understand that, but if I can fly, why would I fall?
Because you wasted all your energy.
You can't do it in front of a
Well, yeah, it depends.
See, what I don't like is being up on something high and having the fear of falling
See,
off
but
of
it
it.
depends
What
on
if you
your
fly too
parameters.
high and then you lack oxygen and then you fall back to earth
Yeah.
and die?
I won't fly that high.
Like, what if a bird poops on you while you're flying?
That can happen. When
What if
you-
a bird pooped on you while you're converting energy? It would be a sad thing, but it happens.
I could just have
yeah.
Wait, is this really just so that you can hit the ball and like fly the golf ball into the hole in one?
No, it's just so that I wouldn't fall anymore and I wouldn't have to be afraid of heights.
I don't know about that.
I don't know. You still have to look down.
You're converting energy into other things. Yes, but the fear that you have when you have a fear of heights is normally not the heights, it's
The fear
falling
of
off of
falling.
them.
Yes,
Well, you can still fall.
I would you're gonna fall into.
Okay, when I'm falling, I'll be like, oh wait, that's right, I can fly. Okay, boom, take off.
I would just
Then why don't you
manipulate the
think that when you're,
probability to 0% that I fall. Then I wouldn't fall.
Wait, by that
Or you
logic,
could
you
just make
shouldn't
it
have
100%
fear of heights
chance
because
that
every
you
single time you
survive.
get up there, you should look down and be like, I can climb right down here, and I'll be fine.
Huh?
And okay.
Okay. All right. Yeah. Okay. We'll move on from there because somehow we managed to turn an easy question into something very difficult. All right, ladies and gentlemen, open up your computers and get to this slide. We worked on this one the other day, but it's where we're going to start again. 41. Let's go. Let's go. Let's go.
You know I'm not gonna do good on
What page?
You know I'm not gonna do my best.
This is slide 41 in our notes. Here we go. Boom. That's it.
You didn't know that.
Give it to someone.
REISN. Okay? We showed you this last week. We talked about how every heating curve for a substance is basically the same as long as it can start out as a solid and end up as a gas. You always have 5 regions, ladies and gentlemen. You have a region where it is heating up as a solid. And one of the things we very rarely get to see, but it does happen, is that solids can be a solid at multiple different temperatures. Okay? So we normally think of ice as being as ice, and if you add any heat to it, then it starts to melt. That is not true. If you take ice out of the freezer in your home, it is probably at about -3, -4, -5 degrees Celsius, which means it doesn't have to heat up much, but it does still need to heat up before it would start to melt. So if I brought an ice cube out here and set it on the table, it isn't going to start melting instantly. It will start to melt once it reaches 0 degrees Celsius or 32 degrees Fahrenheit, whichever one you prefer. Science, we're going to use Celsius. During this point right here, it plateaus, it levels off. It levels off because it is no longer just a solid state of matter. It is now going through a phase change. It is now starting to melt. Now, please understand this. On a test, if I show you a graph like this, and I ask you what is happening in section B, you should tell me that in section B a phase change is occurring. That there is no temperature change. Okay? But I might ask you, what state of matter is the substance in B? What state of matter would the substance be in the area labeled B here? This area. What state of matter would it be in? That's not a state of matter, though. State of matter is solid, liquid, gas. So what state of matter is it in B? And it's in 2 states. It's in both. So there will be some solid existing, there will be some liquid existing. Okay? Now, at the very start of this line, there will be more what? Solid. At the end of this line, there will be more liquid. And eventually, when there's no solid left, now we're into this region here. Okay? So then again, up here in D, what is actually happening in D? What is actually going on to the substance? What process is occurring? Boiling, changing to a gas. We can use the name or we could say what is happening. What state of matter is it in D? It is a liquid and a gas. And again, right after this plateaus, mostly liquid, a little bit of gas. At the very end of this plateau, almost all gas, just a little bit of liquid. And then the other thing that we don't often see, ladies and gentlemen, is you can heat up gases as well. You can heat gases up from not only just after their boiling point, but you can heat them up beyond that. Okay? Now, again, any substance has this curve to it, this shape to it, as long as it goes through all three states of matter. Questions? So, what is being constantly added in this diagram? What is constantly being added? Energy, ladies and gentlemen. Energy is being constantly added. We are moving from way over here with 0 kilojoules of energy to over here with 35. Now, what happens because of that is different in each section. But you are constantly adding energy. Okay? So, why are the lines on the graph going up in A, C, and E? Why are they going up? What is actually happening because you are adding energy? Why?
Because you're getting more heat.
Okay, we're adding more heat. The temperature is rising. I'm agreeing with you. Why is the temperature rising, though?
Because you're adding energy.
Okay, but you guys keep going back to the same thing. What causes the temperature to rise in the substance?
So molecules are moving.
Yeah, the speed.
Thank you. The speed of the molecule starts increasing. So because you're adding energy to them, the particles in either a solid, a liquid, or a gas start moving faster. And as they move faster, that means their kinetic energy increases. That means their temperature increases. So what is happening when the lines are going up in the three segments? Their temperature is rising. Okay? Their temperature is rising. What is happening to the particles of matter in those three segments? So again, the particles in those three segments are starting to move how?
Faster.
Faster. Why do the particles have to move faster?
Because they can't gain more. They can't be more particles. And that's the only two ways that you can get more.
Okay, so what are the only two ways to increase temperature?
Taking kinetic energy, adding velocity around.
Thank you. You are kind of skirting around the word mass there, Miro. You are correct, though. The only way to increase kinetic energy, the only way to increase the temperature of a substance, because temperature is the average kinetic energy in particles of matter. The only way to change kinetic energy is to make particles move faster or to make them heavier. We cannot make the particles in a substance heavier. Once you determine what the substance is, you cannot make the particles move heavier, make them be heavier. The particles in this tabletop do not change what they are just because we are adding energy. They do not become any heavier. The particles in water do not become any heavier. So the only way to increase their temperature, the only way to increase their kinetic energy is to make them move faster. Okay? So as heat is being added and the temperature rises, the particles are moving faster. That is the only way that it can go up. Okay? Now, what's happening in the horizontal segments? In the horizontal segments, we are still adding energy. From here at 5 kilojoules to here at 10 kilojoules, we have added 5 kilojoules of energy along this line. But because the line is horizontal, what is not happening? The temperature is not changing. Why isn't the temperature changing?
Because all the energy is going towards the phase change.
Okay, and again, I'm agreeing with you. But why doesn't the temperature go up?
The energy that is being added is going to the phase change instead of.
That's what Miro just said, and again, I am agreeing with you. But the only way temperature goes up is if what happens to the particles.
They're moving faster.
So what is not happening here?
Particles are not moving faster.
Particles are not moving any faster. So now we need to think about where is that energy going. In section A, it's easy to see where the energy is going. The temperature is going up, the particles have to be moving faster. That is because we have added energy to them. But in B, the temperature is not going up. The particles are not moving any faster. So the energy needs to go to somewhere else. The energy goes to overcoming what, ladies and gentlemen? What did we say exists within solids and liquids that you have to overcome to move to the next state?
Bonds or something.
Very close. We don't call them bonds. We call them forces of attraction. So come back here for a minute, ladies and gentlemen, to the table here in the middle. Come on. So, I have three different substances here. Acetone, rubbing alcohol, and water. Okay? Now, each of these substances is different. We're going to look at them specifically for forces of attraction. Okay? Forces of attraction hold the particles together. These are all three liquids. So if the forces of attraction aren't there, what would they become? They would become gases. Okay? So we're going to take a little bit of water, put it on the table. We're going to take a little bit of rubbing alcohol. Put it on the table. And then I'm going to take a little bit of acetone. And put it on the table. Now, what can you tell me about the forces of attraction of one of these three things? Why?
Much bigger.
Yeah. We put it on the table here, and basically, within seconds, it's gone. Where did it go? Now, it didn't do what? It didn't boil, right? We're not adding any heat to this. It's the same temperature inside that container as it is when I put it on the tabletop, correct? So we're not boiling it. It is evaporating and going off into the air. Now the reason that it evaporates so easily is because the forces of attraction are very weak, small, low, however you want to phrase it, they cannot be very strong. Okay, which one is second? Why?
It's kind of disappearing, not like.
Not as fast as the acetone.
Not as fast as the acetone, but faster than
Water.
the water. So, the reason that things can evaporate faster is because weaker forces of attraction. The reason some liquids don't evaporate very fast is because forces of attraction. And they can be different for all kinds of liquids. The forces of attraction here are fairly strong, holding the particles together. Are there some that are evaporating? Yes, but it is doing it much slower than the alcohol and then the acetone did. By the way, what do you smell? More, I smell more acetone than rubbing alcohol though.
You're also
Because acetone smells like what? Thank you. What? Nail polish remover. Acetone is one of the key ingredients in nail polish remover. Okay? Or booty cheeks or whatever she said. I don't know what. Okay? Point being, ladies and gentlemen, these forces of attraction that we're talking about, all three of these substances could be made into a solid. They could be frozen. Alcohol can be frozen, water can be frozen, acetone can be frozen. All three of them can be made into a gas. All three of them would have that same basic shape. Now, what would be different? How long the lines are in B and D. Which one of these would have the shortest line in D, do you think? Yeah, why? Because the forces of attraction will break apart easier, it'll boil easier. Okay? Which one of these would have the longest line at D? Water. Okay? Water. So that's how this kind of plays in. Please go ahead and have a seat again.
Yeah, no, I can't really want acid.
I didn't smell it all.
By the way, acetone, alcohol, water. We could smell the acetone, we could smell the rubbing alcohol, right? Why?
Because it was in the air.
Why?
Because it evaporated.
It had evaporated.
Why?
By the way, there is only one state of matter that we can smell.
Gas.
Gases. We cannot smell liquids.
What if you get it,
That's called drowning. Get out of the pool.
Okay, well.
Okay? You and I cannot detect liquids for odors. Now, you may be sitting there going, well, how come you could smell like gasoline when you're pumping it then? It's a liquid. You're smelling the gasoline that is evaporated. Even if you smell cologne or perfume, you're not actually smelling the liquid. What are you smelling? The gas that it gives off. The particles that are becoming a gas is what we actually smell. We cannot detect liquids with our sense of smell, ladies and gentlemen. We can detect the gases above them, the gases they give off, but that's all we can do. All right? So in sections B and D here, what's happening to the temperature in those segments? It is remaining unchanged because the energy is going to somewhere else. The energy is not going to make the particles move faster. The energy from the room, from the tabletop, go to making the particles of acetone evaporate. Go to making them go from the liquid state to the gaseous state. Now, doesn't take a lot of energy for that. Okay? Doesn't take much energy for that. And here's why, ladies and gentlemen. If we look at acetone and if we look at alcohol, a little bit of information about acetone. Its boiling point is 56 degrees Celsius. 56 degrees Celsius. That's about 36 degrees over room temperature. That's a fairly low boiling point. Okay? If we look at alcohol, it's 78.37, meaning it's higher. So, what can we say about alcohol compared to acetone? It has stronger forces of attraction because it has a higher boiling point. Water boils at what temperature? 100 degrees Celsius. Higher still, meaning stronger forces holding them together. So we can compare how strong the forces are by how high what is? Its boiling point. How high its boiling point is. Thank you. And here's the other thing, ladies and gentlemen. When you are looking at this graph, how do you find the boiling point of section D here? We bring it across to the y-axis. This is the temperature. Well, if this is where it's actually boiling, when you come across, you can get the temperature where it's actually boiling. That is our definition of boiling point. The temperature at which a liquid becomes a gas. So this line is way up here at 120. So are there stronger forces of attraction here than in acetone? Yes. How about than water? Yes. So a graph for acetone, this is going to be lower, but it's still going to have this same basic shape. Freezing point's probably going to be lower too. Okay? Freezing point is probably going to be lower as well. All right? Same basic shape though. Same basic shape. All right. So what is happening to the particles in those two segments? B and D, sorry. We're still talking about B and D.
They're starting to move faster.
No, they are not starting to move faster in B and D. Because if they were moving faster, what would happen?
Oh,
Their temperature would increase. So what's happening to the particles
Sorry.
in B and D?
they're growing stuff.
They're
They're staying the same.
not moving any faster.
They're not moving any faster. They're not moving any faster. Their speed is staying the same. That is why the lines are horizontal. Okay? They're not moving any faster. So if they're not moving any faster, where does the energy go?
Into changing the phase.
What?
Into changing the phase.
Into changing the phase. They're specifically going to do what?
Break down the forces of attraction.
Break down the forces of attraction. Break down the forces of attraction. Trying to get the forces of attraction to be overcome so that we can go from one state of matter to another. Goes to overcoming forces of attraction and causing a phase change. Okay. We will get to classifying matter in a few minutes, ladies and gentlemen. So, questions on this? All right. In Google Classroom, ladies and gentlemen, please open it up. And there is an assignment there. The heating curve worksheet should be the second assignment down, ladies and gentlemen. When you open it up, it looks like this. And I want you to go ahead and answer the questions on there. We will give you about 15 or so minutes to get this done. You can get it done. You can get it turned in. And then if you have any questions, I can answer them for you right away. When we're done with that, we'll start talking about classifying matter. Yes, Cynthia. I hope so. All right, go to work, please, ladies and gentlemen. I'll be there in 1 second, Cynthia. Yes. Okay. Hayden, I'll end your pass for you. Somebody wrote you on. Okay, Cynthia, what can I do for you?
This part, this be, this part, that be when it
Okay, now, when is condensation going from a what to a what? Okay, so where's it a liquid? Okay, we'll point to one area. You're pointing to a lot. Where is the one area where it is a liquid? Okay, so where is it a gas? So it would have to be the area in between those two. Okay?
Why can't we do that?
What do you mean you can't read that?
I don't know what that is.
We'll just be close. Whenever we take a measurement in science or read a graph, you just need to be close, right? Okay?
And then it's called, it would boil, it starts to boil right here, right?
No. When does it boil? Going from a what to a what? What is boiling?
In here.
Where?
It's either freezing or boiling in this part, isn't it?
No, it's in a single state of matter in that part. What state of matter is it in that part? Okay, so what is boiling? From a what to a what?
So where's that happen?
So it'd be the same.
Condensation and boiling happen at the same point.
So that'd be the same for freezing.
Where are you showing
It
them?
would be down here.
Because freezing is going from a,
Liquid. I mean, from a, yeah, from a liquid.
and here it's a liquid, and here it's a solid, so that's gotta be happening in next, in between those two.
Oh, okay.
Okay? All right? Yes.
What do you mean by semi-free?
Well, that was one of the descriptions of one of the states of matter. So we said in one state of matter, the particles were packed closely together. In another state of matter, they were semi-free. And in another state of matter, they were completely free. So you have to go back and look at that table we gave you and figure out which state of matter I'm talking about to know which part of the graph it is. Okay?
Going off of that, would condense, melt, and freeze be the same?
No, condensation is going from a what to a what?
Oh, I guess.
Yeah.
Okay.
So find the area where it's a gas, find the area where it's a liquid. It's got to be the area in between those two.
And what about melting?
Well, melting is going from a,
Solid.
so find the area where it's a solid, find the area where it's a liquid. There's got to be a line in between. Okay?
And then freezing is going from a liquid to a solid, so it would be the same.
Which, as the which?
As the.
Yes, freezing and melting are the same line. It's a matter of which way you're going on the line. Are you going from the solid to the liquid, or are you going from the liquid to the solid? But the line is in the same place.
Something is melting. Liquid. Solid. So liquid. So I'm gonna do this part. No. Like, this is right here.
For this question,
This is liquid. This is solid. This is liquid. So it's like.
which question are we looking at? Sorry, I'm pointing in an area.
Sorry, it's this one. Where's the?
Okay, so what's fusion?
Energy?
No. Fusion is one of our phase changes.
Yeah.
Go back in your notes and see the picture of our triangle, solid, liquid, gas. Fusion is another name for one of our phase changes. It's not as common as what you and I normally call it, but in chemistry, fusion is the name for one of the 6 phase changes, either solid to a liquid, liquid to gas, gas to solid, gas to liquid, liquid to solid. One of those 6 in that triangle, you'll find it. When you go back and look.
And if the stress is
Yeah, so where's
sorry,
fusion?
frozen here.
What's another name for it?
It's freezing
that's
right
another
here,
name
and it's
for it.
frozen right here. I thought it was condensing here. No, condensing is up here. And make sure it's a different time. No, boiling is different, because it's in different time. The boiler. So it's like going down.
We're supposed to answer these with the letters, like.
What's that?
We're supposed to answer these with the letters?
In the second part here, all I need is the letters. It's happening in A, B, C, D, or E. One of those.
Are we gonna go?
We'll talk about them, sure. But the answer keys are also online for you. The answer keys are Oh my. Hang on. Oh, let me put them out there then. Sorry. Sorry about that. Let me put them out there real quick while you guys are working on this. Sure.
Let me know. Let me know. Let me know. Yeah, yeah. Let me know. Oh, sorry. Sorry. Oh, okay. Those are really good. Really. I'm so sorry that happened. I know. I wish that I hope that she gets
That's it.
Thank you.
That's it. That's it.
I really needed this. You know, like, they won't accept anything else. But this. Okay, thank you.
What's going on?
It's my business.
Sorry.
What is it? Okay, what is this? This is ridiculous.
All right, I just posted the answer keys for you, ladies
Don't
and
ever say that to
gentlemen.
me again.
Why did they not
Don't
go
you
where
want
they were
to?
supposed to?
She's literally gonna eat my face off. Because I know my grandma.
What's it?
No, I need to have back. Last 5 minutes. I need to turn it away. I finished on the new council shirt design. I did it. And it actually is cool. That's really mad about it. I hate this song so much. The words cannot describe how much I hate this song. Why?
So how about using emojis?
You know what? I probably could. Hit me up if you want to.
Hit you up.
Yeah, hit me up.
No, I said emojis. You don't think I know what an emoji is?
Always looking for a way to correct
What's it?
You're wrong? Thanks for telling me. Are you looking at the right worksheet? Which one is wrong?
It's just like, it was a really big thing.
What? What's that? And are we talking about 1 through 4, or are we talking about 1 through 4 on the second page? Oh, you're right. 3 and 4 are switched around. Wait a minute. Are you sure? Are you sure? Update them and check again. Update your worksheet. Refresh it. For which one?
It's literally every day. What?
I'm not following what you're saying.
No, you're not.
For the first one. The answer. You helped me find those.
Yeah, I did.
The worksheet. It's wrong. How's that?
I do that like every day.
The answer key has that, right?
Yeah. No.
What do you mean no?
It had a
That's,
22 before. You just changed it.
that's what the answer key has.
That's not
Maybe
what
you
it
were
had.
maybe you were misreading it.
No, it's not.
Are you sure?
Yes.
Are you positive? Because that's what that one says.
Was I on the wrong? You just updated it. Yes, you did. I saw you edited that.
You saw me editing it. What are you talking about?
I realized coordinates, and I said, I don't know how to do this, and I drew a cat.
Cynthia, it's right there in front of you.
Yes, that was
Okay?
I saw you.
You saw me doing it. When did I do it? Cynthia. I think you're losing it, Cynthia. What? Okay, I'll admit you were wrong. Proof is in the answer key.
Well, okay, so I can do the projectile questions. Those are easy. If there's an entire test on those, like, I would be a happy woman. But there's not. It was one question.
You have to put that one question in.
I wasn't there for that, but that was not that. It's like, I can get started. I'm lost. And I'm like, I literally started, and I'm like, or I don't know how to start at all. I can't go. That's the first thing. I didn't know how to start. Do you know that I only studied vortex? And I thought, it was simple. I like it. You know, like when we do
Are you coming in? Are you hanging out in the hall? What's going on? Yeah. Cynthia had some problems with it, but yeah, I posted the answer key. Cynthia, that's not your phone in your hand, is it? This map that you have the phone in your hand. Right? Right. When you look at the answer keys, there were the wrong answers there. Well, apparently I had a problem with telekinesis, so then I fixed it or something.
because I hated this so much. I'd be like, this is the worst song ever made.
Hang on a second. I gotta go help the needy city.
He rated it 6 times.
What was that? That's just like scary. You know what would be better though? Is if they loaded the car.
You gotta include
Then
that.
I might buy that, because could you imagine walking into the bathroom at night and it's staring back at you?
No, just the stickers.
Would I buy that? Yeah, I know. 40% off is still way too much for something that I have no use for. I understand it. You know, the last time I did the trench,
Right, but I never had to do a trench either. You never know when you will. I do know when I will, because I can go rent one for cheap. Even at 40% off. Oh, you got it? It has no title or registration. I didn't know you needed the title or registration for a trench. I don't know if you do. Although you do have two. Yeah. That's you're warning sign. You're saying no refund. Oh, I know that's a warning sign. That means it probably doesn't. No, it's in wonderful. It's in what?
Wonderful condition.
What is wonderful?
Wonderful in the best.
That is not exactly a term that you use to describe a working object. It doesn't say it's in working condition.
Wonderful is inspiring.
I literally saw one of it. I like take a step back.
Yeah, we'll go with that.
There's one where they were public. I actually can't.
You know what's really funny? That's a bit tricky. And like, sometimes, like, you go to talk to this person and you're like, okay, am I crazy? Am I just being a hater? What's going on here? What's going on here? Why are you guys so positive?
Oh yeah.
What?
Okay, so let's take a look at this real quick here, ladies and gentlemen. According to the graph, at what temperature would the substance boil? Well, remember, to boil, you are doing what? Liquid to a gas. So when you're looking at the chart up above, ladies and gentlemen, you got to ask yourself, where is it going from a liquid to a gas? Well, remember, what state are you in down here? Solid. Gas. So that has to be this line here. So again, you come over and you find that it's somewhere between these two marks here. Now, again, this is 120, this is 140, 1, 2, 3, 4. So each one of these is worth 5, 4, somewhere in there. So we're looking somewhere in the 120s, 126, 124, 122, somewhere in that area, ladies and gentlemen. Okay? Now, this also happens to be the line that it also does what at? Condenses. Please remember, boiling is going from a liquid to a gas. Condensing is going from a gas to a liquid. They happen at exactly the same temperature. Exactly the same temperature. Okay? So again, ladies and gentlemen, when you're looking at this line represents both of those processes happening. The question is, are you adding energy and getting it to boil, or are you removing energy from a gas and getting it to condense? So the same is true when you come down here, ladies and gentlemen. This line is between what two states of matter? Solid and liquid. Okay? So this is the line where it is doing what? Which is called freezing or melting. Now, what's another name for melting? Fusion. That is another term for melting. What is another term for freezing? Crystallization, solidification, any of those. Okay? So understand, sometimes we have more than one term to describe the same process in science. Okay? The common term we use for solid becoming a liquid is melting. However, the more scientific term is fusion. So they will talk about the energy it needs to melt something. They will talk about the heat of fusion. Okay? But that is happening at this line. So again, you come across, you find the temperature that it is happening at, and it's around 42 degrees Celsius. Degrees Celsius. Questions? All right. So again, all I did was label the spots A, B, C, D, and E here. Where does the phase change of condensation happen? Which spot? D. D as in dog, just so we're clear. D as in dog. A substance whose particles are semi-free and moving faster as energy is added to them. Okay? Semi-free is the important part here. What state of matter are the particles moving semi-free in? In the liquid. So what state is, or what place is that? That is in area C. The substance particles are moving the fastest. What state of matter has the substance particles moving the fastest? The gaseous state. The gaseous state, which is E. The particles of a substance are closely packed together. In what state of matter are they closely packed together? They are in a solid. So what section is that? A. Where the phase change, fusion is happening. Okay, what is fusion again, ladies and gentlemen? Melting. So which one is it melting in? B. The phase change crystallization is happening. What is crystallization? Freezing. So what state or what section? B again. Okay, B again. Where the particles in the matter are not moving any faster, even though energy is being added. Where? B as in boy or D as in dog. B or D, either one of those areas. Where the particles are moving faster in a vapor phase. Which one? E. Why? Well, vapor means gaseous state of matter. Gaseous state of matter. Questions, ladies and gentlemen? All right. Tomorrow, ladies and gentlemen, we will start talking about classifying matter. Okay? And scientists love to classify things. Okay? We are going to start by classifying different kinds of matter based on what makes it up and certain properties that it has. So that will be tomorrow's activity. Please again remember, for those who came in late, on Thursday you need goggles for the lab that we are going to do. If you do not have goggles, I will have a box of goggles here that the school sells. I will give them to you. They will add it on to your school fees. You will owe them like $2.25 for a pair of goggles. Now, if you don't want to do that, bring your own. Okay? Bring your own. But you have to have goggles for the lab on Thursday. And by the way, normally I rent goggles to people. I rent them for 50 cents a day because I bought a bunch of pairs of goggles. But it doesn't pay for me to rent them to you because you're going to use them more than 4 times in the year. So you might as well buy them. Otherwise, you're going to be into me for more money than just buying a pair of goggles. But again, if you have a pair at home, bring them with you. Questions?
What is our lab on Thursday?
It's on changes, chemical and physical changes. So, questions?
No.
Wonderful. So what exciting happened this weekend, ladies and gentlemen?
I went to the Tiger game.
Did you? So you were there yesterday?
Yep.
Nice.
Can I show you a video?
What?
Can I show you a video?
Sure, go ahead. Just not on your phone, otherwise I have to take it. I'm kidding.
Oh well. Just when I did this.
This is what you did?
Another encrypted message?
You were sledding? Where were you at?
Trying to
Correct me if I'm wrong. Are they closed at that time?
No.
Then why are there no lights on when you're sledding or tubing?
I know.
You went illegally tubing.
No.
That's
No,
not
no.
illegal. That's a
public place.
Right, so it's a
And
park,
there's
and
no
if you're
gates.
there when the park is closed, that's called trespassing.
It's not a park.
It's
It's
not.
a
My
hill.
parents,
It's Triangle Park.
my parents
Triangle Hill.
Park.
What?
It would be illegal if there was like a tubing stuff running, but I don't think it's running yet.
So you went tubing.
You can't share that with someone. Come on now.
Okay. Anybody else? Anything exciting? Anything? I gotta admit, it was kind of nice sitting there on Saturday morning watching the snow fall down and realizing I didn't have anywhere that I had to go.
Did you go golfing this week?
I did not. I know people who did,
Let's go to this tomorrow.
but I did not.
So that's kind of sad.
Why?
I thought you liked golfing.
I do, but I am definitely a fair weather golfer, and I'm not a big simulator fan.
You would never go with Mr. Nelson again.
What?
Never go with Mr. Nelson again.
I'm not speaking to him anymore after the things he said about me last week. Nope.
Because he's so fake.
People just say that, you know,
I've heard that about him.
Yeah. So like, it's because he's so young.
it's
He doesn't know any better. He's foolish.
Yeah.
Young and foolish.